Hello everyone. Today we are solving AQA GCSE Chemistry question paper 1 higher tier. Guys, this is question paper from May 2018. This is a three-part series video and today we are going to be solving from question number 4 to question number 6. Figure 3 represents different model of atoms. We can see A, B, C, D, we can see few options. Alright, which diagram represents the plum pudding model of the atom? Guys, according to the plum pudding model of the atom, all right guys, what happens is that the positive ion, all right, and the electrons, they are scattered within the structure. All right, so it will be B. Which diagram shows the model of the atom developed from the alpha particle scattering experiment? So when we talk about the alpha particle scattering experiment, we have to understand that we shoot alpha particles in a gold foil, and the alpha particles, some of them passed through, some of them got bounced back, and some of them got slightly deviated. So that represents that atoms are mostly empty spaces. All right, and alpha particles are positively charged, so since they got slightly deviated or some of them bounced back, the core must be definitely positive charge. All right, so C will be the answer, guys. Which diagram shows the model of the atom resulting from Bohr's work? So if we consider Bohr's work, all right, Bohr's work was in more details, showing that the nucleus is a dense place, all right, with the atomic weight in example. So the positives, they cannot be within a particular place just right next to each other, because we know that positive charge will repel each other, so they must be spaced out with some neutrally charged neutrons, and the electrons are found in the shells. Define the mass number of an atom. So to define the mass number of atom, we have to understand that mass number is actually sum of proton plus neutron. Element X has two isotopes. Their mass number are 69 and 71. The percentage abundance for each isotope is 60% of 69, 40% of 71. Estimate the relative atomic mass of element X. So if we have to estimate it, you see the majority mass is with 69 and some of the mass is with 71. So it will be somewhere in between 69 and 71, which is definitely 70. So it's between either 69.5 or and 70. So it should be this one. Chadwick's experimental work on the atom led to better understanding of isotopes. Explain how his work led to this understanding. So basically, Chadwick provided the evidence to show the existence of neutrons. All right, this was necessary because isotopes have the same number of protons, but they have a different number of different mass number. So they have a different number of neutrons. A student investigated the temperature change in displacement reaction between metals and copper sulfate solution. Table 2 shows the student's result. So we can see copper, when it is used in copper sulfate, there is no displacement reaction. So the temperature change is 0. But when iron is used, the temperature change is 13, magnesium 43, and zinc 17. Plot the data in table 2 on figure 4 as a bar chart. The student concluded that the reactions between the metals and copper sulfate solutions are endothermic. Give one reason why the conclusions is not correct. Because all of the experiment the temperature increased, so we will definitely, we can say in a endothermic reaction temperature increases, in a endothermic reaction temperature decreases. The temperature change depends on the reactivity of the metal. The students' results are used to place copper, iron, magnesium, and zinc in order of their reactivity. Describe a method to find the positions of an unknown metal in the reactivity series. Your method should give valid results. This is a very good question, guys, and this is a pretty common question. So to answer this particular question, we would have to use a certain method. All right. So there can be many methods of doing so. All right. One example method would be, all right, we can use a particular acid. Okay. All right. And what we can do is we can use a particular acid and we can add this particular metals to an acid. All right, same number of moles of metals are added in every experiment, same volume of acid is used. We will see that which reaction produces a relative number of bubbles. In terms of, the bubbles can then indicate that if there is more bubbles present, then we can say that this is a more reactive experiment. So thereby the metal is more reactive. All right, and then conversely, the one that will produce the least amount of bubbles, we can say that this is unreactive. All right, less reactive. Okay, this is one approach. The other approach is that we can use a metal with salt solution. All right, so we can basically do, we can put the metal in salt solution. All right, and basically we can use the same amount of salt solution in all of the experiments. Okay, same concentration of salt solution in all of the experiments, and we can add the metal, and what we can see, we can see the displacement reaction. All right, and once we see the displacement reaction, we can basically then the faster the displacement reaction occurs or the higher the temperature increases, all right, any one of those indicators can then be a good indicator of how reactive that particular metal is. Okay, so guys, I'm going to give you the answer in terms of placing the metal in an acid. Draw a fully labeled reaction profile for the reaction between zinc and copper sulfate solution. So when we want to draw a reaction profile diagram, we have to understand that in a reaction profile diagram, if that reaction profile diagram is producing heat energy, the reactants must be at a higher energy level. So we're gonna put zinc plus copper sulfate here, and then we're gonna show a particular barrier, which is the activation energy, and then there will be a decrease in temperature, decrease in a decrease in energy, so which will be represented by a exothermic reaction, because energy is given out. So this is going to produce zinc sulfate, which is the product, plus copper metal will be produced. So this can be represented as activation energy, whereas this portion can be represented as enthalpy change or energy change. A student investigated the electrolysis of different substances. Figure 6 shows the apparatus. We can see DC power supply, graphite electrode, sodium solid zinc chloride, all right, and crucible. Since the zinc chloride is solid, then this particular process will not be able to conduct electricity yet, so the electrolysis is not possible yet. We will need to heat and melt the zinc chloride salt first. The question says, explain why electrolysis would not take place in the apparatus shown in figure 6. So our answer will be solid zinc chloride does not conduct electricity because the ions are fixed in positions and cannot move within the solid, so it cannot conduct electricity. Explain why graphite conducts electricity. Answer in terms of structure, bonding in graphite. So when we talk about graphite, we have to understand that a single atom of the carbon inside the graphite is attached to three other carbon atoms in a covalent bond. So there is one electron in their outer shell which is always free, and that one electron which is always free, it's delocalized. Since it is delocalized, these delocalized electrons can carry charge throughout the graphite because they're free to move within the structure. The student investigated how the volume of gases produced changes with time in the electrolysis of sodium chloride solution. Figure 7 shows the apparatus. So we can see there is chlorine produced, we can see there is hydrogen produced. But if you notice carefully, the chlorine is produced half the quantity of that of the hydrogen. We have sodium chloride solution, we have graphite electrodes. Alright, graphite electrodes are used because they are inert, they are unreactive, and we have a DC power supply for electrolysis. The student made an error in selecting the apparatus for this investigation. How should the apparatus be changed? Give one reason for your answer. Okay, so first of all, we need to see what kind of mistakes we are having here. All right, we will see that the mistake that we have here is that in order to, all right, guys, the mistake the student makes in this particular experiment is that the student should have used a measuring cylinder instead of using test tubes. All right, if a measuring cylinder was used, all right, it could measure the volume. A test tube cannot measure the volume of gas that is produced. Another student used the correct apparatus. This student measured the volume of gas collected every 20 minutes, every minute for 20 minutes. So the data is represented in here, and volume of gas collected in cm3. We can see the volume of hydrogen collected, all right, is a, it's a linear, all right, it's a linear line, all right. So it's directly proportional to the time. However, the volume of chlorine collected is a little bit non-linear, and later on it becomes proportional with time. All right, the reason why actually chlorine shows a graph like this, it's mostly because chlorine is highly soluble in water. So when the electrolysis takes place, the chlorine is produced, but it dissolves in water. But later on, as the water gets saturated with chlorine, and then only the chlorine is able to rise. All right. So describe the trend shown in both of the result. When talking about trend, we can see both of the hydrogen and chlorine has are like a positive correlation. They are increasing with increasing amount of time. All right. So we will take that as a point. All right, we will say the volume of hydrogen is directly proportional to the time, and the rate of the collection of the hydrogen will be, a calculated amount of cm cube per minute. And then up to 8 minutes the chlorine is collected at an increasing, all right, the chlorine is collected at an increasing rate. After 8 minutes the rate of collection of chlorine is the same as that of the hydrogen. So we can see that before 8 minutes, basically, as I told you, the chlorine was having trouble, that the chlorine was getting dissolved within that particular solution, so that's why it was not being collected. So guys, the answer can be written as follows. The number of moles for each gas produced at the electrode is the same. No gas escapes from the apparatus. Suggest one reason for the difference in volume of each gas collected. All right, so mainly I already told you, chlorine will react with water, or will dissolve in the solution, so this should be the answer. We can either write, calculate the amount in moles of chlorine collected after 20 minutes. The volume of 1 mole of gas at room temperature is considered 24 dm cube. Give your answer in standard form. So guys, we can see that after 20 minutes we have collected about 6.6 cm cube of chlorine gas. So what we need to do is, to find out the number of moles, we have to have volume of the gas divided by molar gas volume per mole. So 24 dm cube per mole. So since our volume is 6.6 cm cube, we have to divide it by 1000 to get it converted into dm cube. So now the 24 dm cube per mole, guys, the units get cancelled. The mole is the one that is remaining. So the answer will be, so guys, the answer will be 2.75 into 10 to the power minus 4 moles. Guys, I took the help of a calculator and you can do it too. So guys, that's all for today's video. All right, we are done with question number 6, and thank you for joining the video. Guys, I once again I will tell you, I'm so grateful you guys, you see the videos for so long time. Yeah, and hope these particular videos are helping you a lot. All right, give a thumbs up to this particular video, give a like, and subscribe to the channel, guys. All right, let the channel grow, let your friends know that a channel like this exists out on the internet. And if this makes a little bit of difference in your exam, and I can give you, the knowledge that I'm sharing with you, helps you. All right, please support the channel. All right, let the channel grow. And guys, I am located in DIP metro in Dubai, near DIP metro. So if you are looking for tuitions near Dubai, somewhere near here, all right, let me know, let me know in the comments, and I'll give you my email and we can contact. Guys, yes, thank you for supporting the channel, guys. Best of luck for your exam. See you in the next video. Bye bye.